Welcome to the YesDev channel and the Code Wars series, where we solve katas from the Code Wars website in Rust for fun. So let's get to it. Today's kata is called Vowel Count. It is a difficulty 7 kata, and as always we will solve it in Rust. The task is return the number count of vowels in the given string. We'll consider A, E, I, O, U as vowels for this kata, but not Y. The input string will only consist of lowercase letters and or spaces. On the right side, we see the given code we have to use. So the test program expects a function with the name getCount, which takes a and stir, so a stir reference, and expects as a return value a hue size, so an unsigned integer of size 64. So the only test we have is that abracadabra returns 5. So let's take this code into Visual Studio Code and get right to it. As always, I've copied over the function which we want to implement, getCount, and its description or the instructions we have for this task, as well as the link to the task and the tests that we have. So now let's implement what we have here. So let's first sketch how we can solve this task. So we got a string, which we don't want to look at as a complete unit, but we want to look at each char inside our little string. And then we want to add it or have a count set to 0. And we want to add to this count each time our char is a vowel. So for count plus equals 1 if char equals vowel. So of course we cannot implement it like this, but this will be the code we want to implement or the approach we want to use. Now we can implement this either using a procedural approach or a functional approach, where the procedural approach would directly tell in the program what exactly we need to do. And the functional approach is more like, it focuses on a higher level of abstraction, how to implement this there. Let's first focus on the procedural way. But first, we need to define our vowels anyway, in which we will look this value up. Now the question would be for the vowels, which are up here. We can quickly copy them. And the question would be which data structure we should use for them. So there are many things we can do. In Rust, we can use an array, we can use a slice, or we can use a vector, which are the simplest data structures, most of the time. In most cases, you would probably just use a vec and look it up over this. But if we think about runtime, the best solution would be a hash set, or a set in general, as a set has a constant lookup time, which means while we have to iterate over the entire data structure for slices, arrays, and vectors, we can, in a set, look it up in constant time, and we don't have to iterate over anything. This is because a set or a hash set simply hashes its values and stores them under this hash. And this way we can simply, if we want to look something up, we simply hash that value again and look if that hash is present in our set or our hash set. And if it is, that means we have the value. And if it isn't, then that means we do not have that value. That is a very broad description of a hash set. If you want a broader description or a more detailed one, there are plenty of videos on YouTube that explain how a hash set works. And yeah, it is good practice to have these runtimes for the basic data structures like lists, arrays, hash sets, and hash maps in your head, because those are the most important data structures to use for different things, and they are just to know what the insert time and what the lookup time is good. Yeah, is good to know. So now let's implement our hash set. For that, we simply import the hash set struct from the SCD collections, and then we use the from function to wrap our vowels, and then we simply have to wrap our vowels as chars. Now that this is done, we have our hash set of chars, and now we can implement the procedural approach. For this, we simply use a for loop and iterate over each character in our chars by using this function, which returns an iterator. And now we simply check if vowels contains our character C, where we have to use a reference to not lose ownership of that character. In that case, we will increase our vowels count by 1. Now this is a fairly nice example, where we simply iterate over them and then sum them. So this would be the imperative approach, where we exactly focus on our instructions. We use the chars, we check if it's count, and then we increase this and repeat this for the entire chars in the string. So then let's now look at the functional approach. One big difference between the functional approach and the procedural approach is that we have to use mute here because we need vowels count to be mutable. We don't need that for the for the functional approach. In the functional approach, we can simply go over a string with the fold function over the chars of a string. We can go over with the fold function, and there we provide an init value which would be 0, and then we have to provide a closure, and our closure would take in the accumulator and the next character. And then what it simply does is it checks if vowels contains our C, again a reference, then accumulator plus 1, and else we simply return our accumulator from this closure. And this is done. We can now run our tests. And as we can see, this works. And the way this works is that this fold function will iterate over all our characters by applying this function here, this closure. First, the accumulator in the first call to that closure, the accumulator will be set to the init value, so 0. And afterwards, a char is plugged in from our string. That will be the first character. In our abracadabra example, that would be A. So it checks if A is a vowel and then returns our accumulator, so 0 plus 1. And that result is plugged into the next call of the closure. And so now our accumulator is 1, as it is 0 plus 1. And then B is plugged into the char. And there it is checked if that is, again, a vowel. And in this case, it isn't. So simply our accumulator, so 1 is returned. And this is applied for each and every character we have in our string. And so we do a similar thing as we did with the for loop, but we use this fold function, which folds over this accumulator and each value using the closure. These two approaches are, from the runtime perspective, pretty similar in Rust, as Rust has these zero-cost abstractions, where such a function call and in general default process doesn't doesn't cost much more as it could or would in other languages. And yeah, that makes it much more feasible to implement these, most of the time, more readable approaches. While in this case, it doesn't really matter, both do practically the same. It can be pretty different, and functional programming is seen as easier because you do not have to think about the state, because the state of things is encapsulated in the function. And yeah, the functions are pure, so they will return the same results as long as the same inputs are present. But this would be it for this CodeWars Kata, and now we can plug it into CodeWars and see our results. So now back in CodeWars, we have to remember to copy almost everything. At least we also have to include our our import, otherwise the code won't compile. So let's attempt this and see that it works, and now we can submit it. So let's have a little look at what others used. After looking at everything, most of them used a similar approach. Here the matches function is used, which just applies this closure to the to each char instead of calling chars and then filter, which is done here. So these two are pretty similar. Values that do not match filter or matches are just thrown out, and then the count is gathered. So it's pretty similar to our fold approach. Both are seen as functional. And yeah, many people here chose the functional way. A quite interesting approach is this here, or at least the syntax here is quite interesting. Because the matches function takes a pattern, something that implements the pattern trait, which slices also do. We can just plug the slice here in, and this will give us the same result as calling a closure directly. And so in this case, this works as expected, even though the syntax is a little bit confusing. And yeah, as we can see here, most chose a similar approach. Here regex is defined, and that is counted, but it seems pretty functional, even though it isn't. It looks pretty much the same. And yeah, here also regex is defined, but it's done then in a more procedural fashion with our for loop here, and then the incrementing of the result count. But CodeWars, the people on CodeWars tend to upvote functions, not functions, but tend to upvote solutions that are smaller and more concise. In this case, the concise version is probably as fast as other versions, so the more imperative versions, but sometimes runtime costs are ignored. For example, this contains call to this string is not as efficient as a call to the hash set, or the slice version we looked at is not as performant as using a hash set, probably. And but it's more concise, and so that is preferred in most cases. I would wrap it up here. I hope you had fun. Maybe you learned something about Rust, or how to implement vowel count, or how in Rust we can use very different approaches to most solutions. That's it, and hope I will see you in the next one.